So I have a hello world. So let's use Vim to modify this string. So let's open Vim and open a.out. So by the way, for this video, I'll be assuming that your encoding is UTF-8. So you can check with setEnc like this. I should turn off the keycap. Enc is, or encoding is, an option that controls how Vim internally stores text. And it should match your locale, because it's also how Vim communicates with your system clipboard, for example. So I have mine set to UTF-8. Yours is probably also UTF-8, so it's probably going to be just fine. Alright, so first thing we should do is actually edit this file in binary mode. So let's do edit ++ bin. And so you can see now the buffer changed a little bit. So you can read more about ++ bin over here. ++ bin sets the binary option. And the binary option basically turns off a bunch of smarts to try and make Vim more mechanical. Because when you're editing binary files, you want Vim to be mechanical. But it turns out in my vimrc, I'm actually already turning off all this stuff because I like Vim to be mechanical. I don't want smarts, but so I tend to not use the binary option. But if you haven't turned this stuff off, you should probably use binary, so to avoid any surprises. Okay, so let's look for hello world. So it's right here. So let's try to change it to like foo bar. And then to insert a null byte, you can do Control-V, Control-2, like this. So let's save this, and then try to run a.out. You can see it works. Now let's try to do something different. Let's try to replace this O here with a funny byte, like a hex 80. So let's do R Control-V hex 80, like so. So now we have a HELL, then 80, then comma world, like so. So this looks fine. So let's go ahead and try and run this. But you can see it doesn't work, which is weird. And it turns out, well, so let's look at the hex dump to try and see what happened. So let's look for hell. So if you look at the hex on the left hand side, you can see there's HELL. And then instead of just the 80 byte, there's actually C280, and then comma space. So Vim didn't just insert 80, it inserted C280. And if you know Unicode, you might be thinking, well, you might know what's going on. Vim actually inserted the UTF-8 encoding of 80. It didn't actually insert hex 80. And you can actually see this. So if you go GA to see the code, the character code for this character, you can see it says hex 80 again. Everything looks fine. But if you go G8 like this, now you can see the actual underlying bytes in Vim. They are C280. So G8 is the binding that we can use to see the underlying bytes. Like inside of Vim's representation, and since our this G8 actually assumes that the bytes are UTF-8, but again our encoding is already UTF-8, so everything works fine, and it actually shows you the bytes, the underlying bytes. So that's the reason that this G8 is not working. So there is a way to insert raw invalid UTF-8 inside of a buffer, which is what we need to do now. And so let's do this. So do I get rid of this? I'll get rid of this, 80. And now to insert a raw hex 80, the actual byte, now the character, you can go Control-R, Control-O equals, and then hex 80 like so. So this is, what I'm typing in right now is a string literal that contains the byte 80. So it doesn't contain the character 80, this is a string literal with the raw byte 80. And then hit enter. And now if we hit D8 to see the UTF-8 bytes, you can see that at the bottom now it actually says 80. So this is an actual true 80 byte. So for this I used insert mode Control-R, Control-O. So Control-R, Control-O is like insert mode Control-R. It inserts a register, but it does a lot less magic. And the register we use, by the way, is the expression register, which is documented here. Okay, and so now if we try to run this, you can see everything works fine, and we have hell with a broken byte and then world. Okay, but still, this doesn't solve the fundamental problem. The fundamental problem is that characters we can edit in the buffer don't match up with the characters that are on disk. So there's no one-to-one relationship between them. So for instance, replace mode won't work, because if we try to use replace mode works on characters on Vim, but those might not actually correspond to single bytes on disk, so the length of the file is going to change and everything's going to blow up. So let's change this back to no. So the trick, which is like the purpose of this video, is to edit the file with a file encoding of ANSI or Latin 1. So you can do this this way. And again, you can see the buffer changed a little bit. So we used ++enc, which is documented here, and ++enc sets the file encoding option. You have to be careful about this here. I got tripped up a few times. But so it's ++enc, but it doesn't set the enc option. It sets the fenc option, which is file encoding. So you just have to keep that in mind. And file encoding is an option that determines the encoding of the actual file on disk. And so when Vim reads a file from disk, it'll use fenc to convert it to encoding. So it'll convert from fenc to enc and actually store that inside of itself. And when you go and write the file, it'll decode from enc to fenc and then store that on disk. And the reason that we want Latin 1, oh, by the way, there's probably a there's a big list of encoding names. Yeah, here. So there's a big list of different encoding names, and ANSI is an alias for Latin 1, so that's why we use it. And the reason that we want Latin 1 is that Latin 1 is a 1-byte encoding scheme, so every character corresponds to 1 byte on disk, and also it matches up with Unicode for its whole range. So the first 2 blocks of Unicode are ASCII, followed by the Latin 1 supplement. So they match up perfectly, and that's the reason that this works. And so now that we've edited the file in Latin 1, we have a one-to-one correspondence between the characters that we can edit and the actual bytes on disk. So if we go to the O again, and we do R Control V hex 0 to insert a 0 byte, you can see if we go G8, it still looks like it's broken, but it's actually not broken. So if we open up the shell and then run it, you can see it still works. And the reason that G8 shows C280 is that Vim internally, it actually stores all of this in UTF-8. But again, when it writes to disk, it uses fenc, so it will convert the UTF-8 encoding into an actual byte, a single byte. And by the way, just for quality of life, if you don't like all this caret stuff, you can set display plus equals uhex, and now you can see you actually find all the control sequences are replaced with hex codes, so it's easier to see. And if you don't like all of these Latin 1 glyphs, so you can by the way, you can see the actual hex code for under a Latin 1 glyph with GA, and it will show you at the bottom. So it shows you the ASCII code and some other information about the character under the cursor. So that's what I usually use. But if you don't like those and you want those to be displayed in hex, you can set isprint equals or not 1 to 255. That should work. Yes. And so now you can see we only have printable ASCII and raw hex. So this is nice. So what was I going to say next? Oh yeah, so let's try and actually insert some UTF-8 inside of this string just for fun. So I'm going to insert, let's say, an integral character. So what the fuck? What the hell? Is this because of isprint? Huh. I should do this in hex. So 80 to FF. So it's broken. C0, still broken. E0. F0. Okay, so it's going to be E0 to F0. To F0. Okay, and then let's do E8. Still broken. E4. still broken. E2, still broken. E1 is back. So E1 to, so wait, is it just E2? It's just E2. Huh. I'm just trying E1 and E3. Yeah, so it's just E2. Yeah, this is looking like a bug, because E2 is the first byte in the UTF-8 encoding of the integral character. Anyway, okay, so let's just discard all that. So I'm gonna reset display and reset this print just to get rid of all of this. So anyway, we have an integral character. The reason I wanted an integral character is we can see its UTF-8 encoding, which is E288AB. So we can actually put that now in our string literal in here. So E288AB. So let's go foobar E288AB, and then for null byte control V, control 2 like this. And to insert these characters, I was using insert mode control V, and specifically this here I was using the hexadecimal escapes. And so if you do control V X and then two hexadecimal digits, it'll insert that character. Okay, and now since I used replace mode, and every character corresponds to 1 byte on disk, this should all work correctly, and the length, we shouldn't segfault, like the length was of the file shouldn't be affected. So let's try and run this, and you can see it works. Yeah, so that's it.